Okay, today we're going to be looking at day 2, our surface area of pyramids. So this should be our last lesson on surface area. So very much like when we're talking about our prisms and our cylinders and our cones, we're going to be looking at our pyramids. Now really there's one formula for the regular based or equilateral based pyramids, and there's another because there's a slight difference when we're talking about our rectangular pyramids. So let's look at that nice, easy, basic one with our regular based. And when I say regular based, let's go and look at the base of this. It really is a square. That's why I said regular, because every single side is exactly the same. So that's a regular based or square based pyramid. Here we do have a triangle, but again, all the sides are exactly the same. So that's our equilateral triangle base. So again, every side is exactly the same on the base. So this is going to be our formula. To find our surface area, because remember, surface area means you're covering it, like wrapping it in wrapping paper with a present, not president. So which means you need to find the area of every single side. So with this pyramid, all of the sides up to the apex are triangles. And those triangles, when the base is exactly the same on every side, are the exact same triangle. But it's being pushed up to that apex, so it's getting smaller and smaller and smaller all the way up. So how we're going to calculate this is we have to find the base area, the area of that base that we just talked about, and we're going to add it to half of the perimeter of the base. The perimeter, remember, perimeter, we just add up every single side. So the perimeter of the base. And then we're going to multiply it by the slant height. The height of that slanted side of that triangle. So let's look at this first problem. I've given you that formula for that surface area. And the surface area is going to be the base area. Well, look at that base. Again, it's a square. So the base is going to be, area of any square is just 4 times 4 in this case. Base times height, exact same number. Then we're going to add that to half the perimeter. Well, when I add up the sides, and again, every side's exactly the same, 4, 4, 4, 4. 4 times 4 is going to give me 16 when I add those all up. And then we've got that slant height, that slanted height of that triangle, which is 6. So let's go ahead and find the answer here. 4 times 4 is our 16. Well, half of 16 is 8. And 8 times 6 is 48. So the surface area of this pyramid would be 64 meters squared. So there would be my answer for the surface area of that shape. Same thing, even if it's a triangular base. If it is an equilateral, all sides are the same, means those triangles up to the apex are also all the same. So we're going to use that same formula. Surface area is going to be the base area. Now remember, on a triangle, area of a triangle is 1/2 the base times the height. Well, the base of the triangle is 6. Now the height of the triangle, not the height of the pyramid, the height of the triangle is 5. And then we're going to add that to half the perimeter. And when you look at the perimeter, again, every side is exactly the same. So 6, 6, and 6, which is 18. And then we're going to multiply it by that slant height, which is 10. So when we go ahead to make that calculation, half of 6 is 3. 3 times 5 is 15. And now do the same thing here. Half of 18 is 9. 9 times 10 is 90. The surface area of that triangular pyramid is 105 kilometers squared. Pretty easy, pretty self-explanatory of getting all the areas of every side. Now there's a little bit different of a formula if we're talking about a rectangular pyramid, because if you look at that base, this base is a rectangle. The sides are not all the same. And if those sides are not all the same, that means the triangles that are going up to that apex, well, they're not all going to be the same either. The triangle here is going to be the same as the triangle on this side, but the triangle here in the front is going to be a little different because they have different bases. They're also going to have different slant heights, but the one in the front is going to be the exact same as the one in the back. So when I go ahead and give you this formula, we're still going to find that base area. That doesn't change. We have to know the base area first. Well, that base, we already said it, is a rectangle. Finding the area of the base, 5 times 2. But now what we need to do is find the area of all the triangles up on the top. But again, we don't have to find them individually because the left and the right is the exact same size triangle as each other. And the front and the back are the same exact triangle as each other. So we really only need to find the base of one triangle times the slant height of that one triangle. So let's go ahead and look at it. Let's look at this one first. The base of this triangle is 5, but the slant height of that triangle is 6. And now we're going to add that to, we have to look at the other triangle. We just did the front one. Now let's look at the one that's the same on the left and the right. That base is 2. And the slant height of that triangle is 7. So when we go ahead to do that calculation, we get 10 plus 30 plus 14. And when we add those all together, we've got, there's my friend saying hello, 54 inches squared. And there is my surface area of a rectangular prism. So that's the only difference if the base is a rectangle where the sides aren't all the same compared to if they are. So if you have any questions, go ahead and write them down and bring them to class and we'll cover them.